Welcome to Happy Maths Hour with Toni and Caroline. Today we're talking about the Mobius strip. Toni, tell us what we can expect today.
Okay, so if you like to show the PowerPoint, Caroline.
Oh, okay, we're not going. Okay, here we go. I'm going to do it full screen on the PowerPoint. There you go.
So Caroline and I are going to have some fun with the Mobius strip, and we hope you'll want to try some of these things for yourself afterwards. So first of all, here's an Escher picture made from a wood engraving.
Sorry, did you say fun, Toni?
Fun. I did say fun.
Oh, ants. Oh, but it's fascinating to actually imagine the path those ants are taking and where the path starts and where the path finishes.
You might like to take your finger and follow the strip around with your finger, seeing where the ants would get to. And which side are they on? Are they on the inside or the outside, or both sides?
Or the top
Can they
or
get
the
from
bottom?
the inside to the outside? That's
and
a Mobius
which is
strip.
the top and which is the bottom?
Well, I did something very simple with my little Ladybird, and I have a cylinder here, and here's the Ladybird, and he's on a track inside, and there's no green grass on his side at all. If you imagine him going around to one of the ants, he's a much more attractive ladybird, and he doesn't get onto the grassy side of the track at all. But here, you see, here he is, and he is just about to cross over. If you can see, I've got my ladybird here. Where is he? And
hold on, Toni. No, they can't see. 1 second. Let me make it so they can see you.
There he is. He's on the Mobius strip, and he is just about to cross onto the grass. Okay, and he can go round on the grass, and here he is going. Oh, wait a minute. He's going the other way. I don't want him
I've never
to go
seen
that way.
a ladybird go backwards.
And then he's it's because of the mirror effect of the screen here.
Dear.
I did the wrong thing. Sorry, everybody. But now he's traveling on the grass, but he's about to go back.
Go slightly to your right, Toni. Move it.
Right,
that's it. There.
Right. He's still traveling on the grass, and he's still going the same way. And now he's back on the track, which isn't grassy at all. So he, on the Mobius strip, can go on, and now he's back on. Well, he's going that way. I'm having to imagine doing it right that way. He's going.
Yeah.
Well,
you're doing.
That's.
Yeah.
Believe you me, I'm sorry for my mumble, but I'm trying to do it as if I was looking in a mirror, and I'm sure there's some control here that I could switch it over so I could see it without being mirrored.
There is absolutely no need to apologize, Toni. We all experience it, the reversing things when you're doing online events. So, but I'm much happier with the ladybird than the ants. I think the ladybird was lovely.
It's my cookery timer, actually. I've got sophisticated ones on my cooker. I still use the Ladybird. Okay, so the difference between the cylinder and the Mobius strip, how are they made? It's a little bit of topology. So they're both made from a rectangle.
You almost ate that word, Toni. The word is topology for those of you that don't know it or have forgotten it. I just want to say it nice and clearly because this is for mums and dads and things. Topology is so fascinating, and my favorite thing about it is this wonderful Mobius strip. Sorry, go ahead, Toni.
Well, it's not something that is usually taught in school. It's quite an advanced subject. I mean, we're just playing with some simple ideas. Now, if you take the cylinder, the ends of the rectangle are just joined cleanly without making any twist. But with the Mobius strip, what you do is you to make a half twist and then join the ends together, and you get a Mobius strip there. Now, here's another way of making a Mobius strip. If you take a triangle and, well, just a strip, and make it into a triangle, and this is not joined together yet, but do go fold under at one corner of the triangle,
shall I
under
demonstrate
at the
it,
next,
Toni?
and then over. Yes, do show us, Caroline. It'd been interesting to see that.
So I don't have a triangle, I have a strip. So with my strip, I'm going to start by going under. Is that it?
Yes, and then under again.
And then under again.
And then over.
And then over.
And then, if you join it there, Caroline, just put a bit of, hold it. Now, you don't need the tape really if you just hold it, but you can put some tape on. And now you've got a Mobius band.
Let's see. Oh my goodness. Look at that.
Well, it's got a half twist in it. And you can see that it's a half twist because Caroline had marked one edge with a wiggly line and the other edge with a hard line. And they are, the half twist joins the wiggly line to the hard line. I'm just going to
show you. There's no, that's how it started. Straight line on one edge and curvy on the other. And we ended up with a half twist and the curvy joined the straight and the straight joined the curvy.
Now, if you're interested, you could experiment for yourself with other folds at the corner of the triangle, because we did under, under, over. Well, what would happen if we did 3 unders? We're not going to do it now, but what would happen if we did 1 under and 2 overs? There's different possibilities there. But what we will spend some time on is looking at what happens for a square. So here we've got at the corner of each corner of the square, the strip folds either over or under again, like we just did for the Mobius strip. And we label the folds clockwise. And we're going to think now how many possibilities there are of doing these different folds at the corners and what's going to come out of it and how many possibilities there are. Caroline, are you going to demonstrate this?
Yep. Ready? Okay. So we're doing the first one, right?
Yes, fine. So that's
over. So I've got just a strip here. So the first one, I'm just going to go over.
And then under.
And then under.
And then over.
And then over.
And then under.
And then under. And it comes together. So, and here's one I prepared earlier. So I've done the same thing with that. And this is going to be, let's see, what do you think it's going to be? Is it going to be Mobius? Will it have a twist? It is a cylinder.
Just an ordinary cylinder. Okay.
It's just a loop with no twists whatsoever. A bracelet, in fact.
Right, okay. So let's try the second one down, Caroline. Under, 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 over here.
So I've got under, whoops, under, and, oh, that one's a bit too long. Under, over.
And over. Under, over.
That's it.
There you go.
Under, over. And here's one I prepared earlier. And this time, wait a minute. Wait a minute. I've got one twist there. I've got one twist there.
Oh, is it two half twists?
I beg your pardon. It's 2 half twists because it only goes from facing down to facing up. So it's only gone halfway. It hasn't gone all the way around. So 1 half twist there, 1 half twist there, making a whole twist. So it's two half twists making a whole, and the rest is just
So that isn't Mobius, because the Mobius only has one half twist.
It'll have an odd number of twists, won't it, of half twists?
Yes.
Okay.
So what about this last one, which is 4 unders?
Okay. Under, 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 under. Give you that effect. And one I prepared earlier. Let's see what we've got.
Okay, now
we've got half a twist there. Every one of them is half a twist, Toni. It's got 4 half twists. I can't undo those at all.
Is that 4 half twists? That would be 2 twists.
That's 2 twists, yeah. So it's an even number of twists, or a whole number of twists.
I'll do it, Caroline, and see whether it really has got 4 halves, or has it got just 2 half twists?
It's got 1 half twist there, very clearly. 1 half twist there. I cannot straighten those out at all. They are definite twists. I could actually cut it open and literally untwist them and count them if you like.
So it's got an even number of twists, hasn't it?
But you know what, Toni? It's got a whole number of twists, because if it's got anything under half, then it's a Mobius, and or it might be, that could be an experiment you could attempt. Well, if it's got a whole number of twists, then so a half and a half is 1. This has got 2, so it's not. I predict it's not Mobius, and you can tell it's not Mobius because the black. I've got 2 edges on this, 1 black edge and 1 red edge, and the black edge joins the black and the red joins the red, which means it hasn't had that Mobius twist. But what's the big deal about this Mobius twist, Toni? I mean, so what? No?
Well, the Mobius strip has got to have an odd number of half twists, or why? Half twist, and if you do more half twists, then it goes a bit further. This is.
But what's so special about it? Why are we searching for a Mobius?
Oh, well, because we were talking about the Mobius strip, we just wondered if we could get it from a square.
Oh, I see.
With an even number of the folds that go under and over.
So we definitely managed to get it from a triangle.
Yes.
We're so far haven't succeeded in getting it from a square.
Yeah.
Okay. So is it possible?
So I said on my slide there that there was 1 twist on that last one, Caroline, and I think you've just proved me wrong. So I think I made a mistake there, but I think that's something we should just check, because what you showed is that last one with 4 unders. You said that there were 2 twists there. So I'm just going to correct that. And I believe you. I believe. But
this is, you see, in the back office, ladies and gentlemen, this is actually what we do when we're doing our rehearsals. Changes get made to the PowerPoint.
Well, we did do it in rather a rush because Caroline's had flu and she's not been well. That's my excuse.
No, this is grand. The thing is, there's no such thing as a mistake, right, Toni? There's only magnificent
learn
mistakes.
From your mistakes.
Yeah. And hopefully the audience is learning as well. And there's no
one useful
mistakes.
Yeah, one useful bit of school maths that you get out of this, which is really nothing to do with topology, is how many possibilities. And it's a little experiment that you can ask about, because it's something that you need to understand when you come to probability. If you've got 4 different possibilities, 2 things happening at each corner here, how many possibilities? Well, we can list them. So we can either have 4 unders, which is the one we did, one you see on the screen, which is the pink one, the one we've really puzzled about whether it's got 2 twists with 4 half twists, or whether it was just 1 twist, as I labelled it. I think now.
Well, perhaps you can test this and make a comment for us. We'll come back to the video later and test it, and you can decide whether it's got 4 half twists or 2 half twists, and let us know.
But
or
coming
something
back
else.
to the question of how many possibilities, we're going to look at all the possibilities, and I've only listed 5 of them. Okay, the ones where you've got 4 unders, which is the one on its own, and then when you've got 3 unders, you can have them in those sequences. You can have under, 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 over, or you can have under, under, over, under, and you can see there are 2 more possibilities there. So 5, and now here there are 6, okay, because here now there's all the ways in which you can have 2 unders and 2 overs, and the different permutations of the unders and overs. I mean, the permutation word just means how many different ways can you arrange them. And what else? What have we not looked at so far? Well, we haven't looked at having 1 under or no unders. So we've got 4 unders, 3 unders, 2 unders, and now there's the list of 4 possibilities for 1 under with 3 overs. And finally, the last one there has got no unders at all. It's got 4 overs. So that's how you work out in a systematic way how many possibilities there are in a problem like this. And this is 16 altogether. But because you've got 4 choices, and at each choice you have got either one of 2 possibilities, under or over, it's 2 times 2 times 2 times 2 permutations, or if you like, arrangements. Okay, so we've done a little bit of the sort of work that the young people do have to do in school about permutations and combinations there. This is permutations. And there's a connection with the Mobius strip, but we didn't find that we could make a Mobius strip if we had an even number of these half twists.
No, we did not. So I wonder if you can make a Mobius strip with a pentagon then. If you have an odd number of edges on a shape, will you be able to make a Mobius strip with odd numbers and not make it with even numbered edges?
There's something to explore. Now, sometimes people think about topology as being like sort of the rubber sheet sort of geometry. So what you have is something which, like the plasticine there, you can mold, but you mustn't make any new holes in your piece of plasticine. So if you start off with that middle strip and you start off with a ring or a torus, okay, a mathematical word for it is a torus, like the hairband there, you see, if you stretch that out and blew it up, it would, or the sort of ring you have to stop you sinking if you're not a good swimmer. It's floating ring. So if you start off with that and then you gradually mold your if it's rubber or plasticine, you gradually mold it, and then you push down. You're not actually making a hole. The surface, the inside and the outside of the cup are all part of the same sort of surface. The hole there is through where you eventually form a handle to make the teacup. So
wait.
Topologically, they're the same.
You're saying that my coffee cup is a torus?
Yes. If it was made of plasticine, you could squash it into a torus. Yes.
Oh, I suppose that does make sense, because once upon a time this was clay or some such thing. So before it was formed, you could have actually played and made it into a torus and then formed it into a coffee cup and kept the hole. So topologically, having one hole and everything else being a constant surface, it's a torus. That is interesting.
And
who knew?
If you've got a sphere and you make a loop on the sphere anywhere, you can shrink the loop to a point. You can always do that, even if it starts off with the longest loop you can make around the equator. you can still slide it up on the sphere and shrink it, make it smaller and smaller and smaller until it goes into a point. But
so
with
this is on the surface of the sphere. This isn't a hole through the sphere you're talking about here.
I'm just talking about the outer surface, and that's what we're looking at. We're looking at topological surfaces.
Okay, so what's the connection between the torus and the loop on the sphere?
Well, it's pointing out there's only one loop on the sphere. But when you come to the torus, there's two possible loops. You see, the red loop, you cannot shrink to a point because of the hole.
Because the hole has to be there, or it isn't topologically the same anymore.
Yes, and the black loop, you actually can't shrink to a point either. There's a third loop that you can do on the surface of the torus, which is like the one on the sphere. But the two that you see are different sorts of loops to the one on the sphere.
Okay.
Neither of those can be shrunk to a point. And one of the things that topology is about is this sort of thing, and different functions are studied on topological surfaces, and the function changes as the value of the function changes as you move around loops, and sometimes they come back to where they started, and sometimes they're things that can be shrunken and sometimes not. I mean, there's a whole world of topology out there, and we're just hardly scratching its surface, really.
Yeah.
But now here's a thought. What's the topological difference between a sweater and a pair of trousers?
Oh my goodness. Okay.
Well, we were talking here. We were talking about how many holes there were. Now, when we put a sweater on, how many holes does it have?
Well, there's the head, there's the two arms and the two legs. That's 5 holes. But then through the center is kind of a cylinder. So the head to and the trousers have 3 holes.
5.
Yes, where'd I get 5 from? 4.
I think so. I mean, yeah, yes, you've got a bottom edge, the edge around your neck, and each of those is a hole.
And as we all know, 2 plus 2
you put your arms out the other 2 holes. Yeah, 4. Yeah, and 3 for the trousers.
Right. So they're different topologically because they have a different amount of holes.
Yes. So here's a Mobius strip, and you can see there's a half twist in it, and you can see that, like the first strip that we showed for the ant, with the ants on it, and like the one I showed with my little ladybird on it, you can go from, there really aren't two faces to that, because you can go all the way around and keep on it, and you can go from what appeared when it was a cylinder to be an inside and an outside. Now it's all one on the Mobius strip.
It's like a never-ending roller coaster. and the bit that was facing inwards turns to face outwards. The bit that was facing outwards turns to face inwards, and it goes on forever.
Yes. Yeah. Yes. So we've got a story to tell about a matador and a bullfight. But you were telling me the other day, Caroline, that you thought they might have stopped having bullfights in Spain now.
I double checked, and the information I had was that it was about Sevilla, and apparently in Sevilla that's it. They're not having any more actual damaging bulls fights, but their bullfights continue in other parts of Spain, and I think Portugal have stopped actually torturing bulls, but apparently South America haven't. There's places in South America where it
And you
continues.
think it depends in Spain where you are, from
Yeah.
one region to another.
It seems to depend. That there is a movement in Spain. Apparently, it was kind of delayed by COVID. So, but there's definitely a movement in Spain to halt the torture of bulls. So we're doing this virtually. No bulls are being hurt. In fact, it's been designed otherwise. Let's see what happens to this bull.
Yes. So we're going to have this bull fighting, this bullfight actually on a Mobius strip, which is a very weird thing to do, but just for fun. Yeah. So it's a bit like fox hunting in this country, isn't it? I mean, there's still a lot of people in this country. It wasn't so long ago that we stopped doing fox hunting, and the dogs tore the poor old fox. Once they caught it, they tore it to pieces, didn't they? So some of us really, Caroline's pulling a face, we really hate the idea and couldn't imagine
And the bull. I lived in Spain for 10 years. I couldn't watch a bullfight. It was horrible. Awful.
So do you have them on the television in Spain as well?
Sundays. Oh my goodness. It was Sunday afternoons. Football and bullfights. It was, and then the bicycle, if they had the Tour de France or the Tour de España, whatever they called it. But bullfights every Sunday during the season, yes. No, I couldn't watch. No, couldn't do it.
But it's actually very, very like the fox hunting here. I mean, there's must be some people in Spain who don't like it, and other people who think it's it's the national sport, and it's in some sense part of their history and tradition, and it's important, and they enjoy it.
Yes, you're quite right. There are people who don't want to see it go, absolutely, and there are people who can't support it, so who abhor it.
I mean, it's only been in the last 20 years that we've stopped fox hunting in this country. And there's still a lot of people out there who miss their fox hunting, I think. I don't think they miss the kill. I think they miss the chase, actually, rather than the kill. They miss the dressing up and the being on a horse and the chase and the excitement of all of it. So what are we going to do with our matador? Okay, so the bull is going to charge past the matador and run around the imaginary Mobius strip in this mathematical bull ring space. And we're going to see what happens. So I'm going to, now I'm going to minimize my, I'm going to try and minimize my PowerPoint so I can show you this film and maximize.
If you pause for a moment, Toni, then I'll be able to edit this out and we'll go smoothly from one to the other. And we do the edit.
Now, what you see is the bull charging past the matador as I said he would, and he carries on round the Mobius strip, keeps on going, and the matador's waiting for him. But
he's ready, he's poised. Look at him with his sword,
but when
the
bull gets there, the matador's taken by surprise. The bull charges past, piercing the poor matador where it hurts, and the bull keeps on going and goes on round and round again, around, and keeps on going and meets the matador again. And the matador's picked himself up, and the matador has stood up bravely to the bull, but the bull has now, oh dear, he's charged into the matador. Poor matador. Poor matador.
And that means that the bull gets to live. The bull gets put out to pasture, and that's it. He doesn't have to do another day's work in his life.
Well, he's an honourable, well, how often does that happen, Caroline?
Not only when you involve the Mobius strip. Doesn't happen very often.
Oh my goodness. Well,
I
I
have to
don't
get more
know whether.
Mobius strips out there to save the bulls.
Yes. So that is the strange thing we wanted to show you about the Mobius strip, really. Here it is. There he is when the bull meets the matador on the first circuit.
The very confused matador.
Yes. The bull runs round one circuit, okay, and meets the matador, taking him by surprise and piercing the matador with his horns. And the bull goes on running for a second circuit, injured and very shot matador picks himself up.
And that
Well,
was your Happy Maths Hour story time.
oh dear, aren't you crying tears, buckets of tears for this poor matador?
Yeah, I don't like it when anybody gets hurt. So yeah, I'm like, just stop the whole business, and that's fine.
Yeah.
Win-win.
But it does show you something really rather weird about this Mobius strip, doesn't it?
Yes, we're still working on understanding this. You know, we've been attempting to
I'm
make a
now
Mobius strip. You made a Mobius strip there. What do we do? What's it all about?
Yeah. Okay, so here we have a blue line drawn along the center of a cylinder. And if we cut all the way around the blue line, what do you expect to happen? The resulting strip, what would it look like? Would it be narrower or longer? How many twists would it have? So Caroline, would you like to show us?
Couldn't find my cylinder for a moment there. Right, let's get the correct screen up. And so we have, well, it's a bit of a wonky cylinder. So what am I doing? I'm cutting it?
All the way along the middle.
All the way down the middle. So I've got a line that goes all the way down the middle. So what do you think is going to happen?
Imagine
what's going to be the end result? Is it going to make a Mobius strip? Is it, I'm cutting a cylinder in half along its waistline, let's say. So what am I going to end up with?
How many strips? Oh, and will they be narrower, longer? Will they be twisted? Oh, you seem to have two cylinders.
I'd have two cylinders that are half the height of the one we started with.
No twists.
No twists.
Okay,
no twists at all.
So that's what happens with a cylinder.
Okay.
So then, supposing we do something similar on a Mobius strip. So with the blue line drawn along the center of the Mobius strip, and we've also got red lines, but we'll come to those in a minute, on the one on the, as in the one on the right.
Something very interesting happened while I was drawing that line. And if you have never drawn a line along a Mobius strip, I suggest you do it. It's quite interesting.
It is actually. Now Caroline she's now going to cut along the center of this Mobius strip. And what would you expect to happen? All right, she's going to show you.
So what do you think I'm going to end up with? Am I going to have two cylinders? Am I going to have, well, how thick is it going to be? Am I going to have two Mobius strips? What am I going to have?
Oh, you've only got one strip, Caroline.
I've only got one strip. It's,
oh my goodness.
A strip that's twice as long as the one I started with.
And half the width.
How many twists have I got? I've got, let's see, that part is a cylinder there. Let's go into where I've got all the twists here. I've got two twists, Toni. Can that be possible? Or is it
Oh,
two
you
half
mean
twists.
2 half twists? I don't think you
That's
can have
going all the way. That's one full twist. That's one. It's 1.5 twists. It's 1.5 twists is what I've got.
That's
that one goes
interesting.
all the way around white, all the way around back to white again. And this one twists from white to yellow, which means it's a half twist, I think.
So we're saying it's got 3 half twists.
No, actually, it's got 4, because that, if I do move this along, it's white to white. It's actually got 4 half twists. I haven't got an explanation. I might be wrong.
I think it's got 3 half twists, Caroline.
Yeah. Well, I'll tell you what I'm going to do later, and you might want to do the same. Is I'm actually going to draw a line along it, and then I'll know.
Do you want to do that now? Do you want to do that now?
Yeah, absolutely. Because that's the magical thing about. So here we go, all the way down the middle. This is the other great thing about Mobius strips is it's all. Some people are experts. I'm not. I love to play with them, and I'm always discovering new things. And there's never a moment where I can't say, "Oh, let me test this. Let me do that." And somebody will say, "What if you did that?" And the answer is, "I don't know. Let's give it a go. Let's do it and see what happens." So we're seeing if this is actually a Mobius strip by drawing a line. And I've only drawn a line on one face, Toni. This shape has 2 faces.
Oh.
Who knew?
So you were right, Caroline. Well done. What you said was you had 4 half twists.
Yep.
So somehow or other you've untwisted it.
So I can make a square with this. I can make a rectangle. I think it might be beyond my ability to make a square right now, but I can certainly make a rectangle with it. And that folds there, under, over, under, and I can make a rectangle with it, which shows us, according to what we were investigating earlier.
Interesting. It connects, doesn't it?
Yeah.
Yeah. Okay.
This is an over, under, over, over.
Well, that's interesting. So we've got 4 half twists there.
Yeah.
Fantastic. Okay, so now what about showing us what happens with the red line? Now the red line is a quarter of the way across the strip. And what do you expect to happen here? Okay,
right. Well, I lost my scissors. How can one lose one's scissors when one is doing a live show? I have no idea where they are. Right, okay, here we go. And red line.
Keep on cutting.
Again, if you actually do the activity of drawing the line in the middle and then drawing a line halfway across the, just as I've done here, it's again interesting. Just predict what's going to happen, and then see what actually happens with the drawing part. Now, what is going to happen with the cutting part?
You're just keeping a quarter of the way across from the same edge as you go on.
So I've clearly got something that's going to be that wide. Am I going to come to this the blue line, and end up with 4 strips that wide? What shape are the strips going to be? And the great thing is there's no right or wrong answer to this, because it's all using your imagination, having a whoop, here we go. Oh, and I've got, I've found out where my other scissors are now. Okay, so I've got a strip that's half the original width. I've got a strip that's a quarter of the original width, and here's another strip here that's a quarter of the original width. How many strips have I got like that? And wait a minute, they're intersected. And this double width strip is the original strip. It's a Mobius strip. It's got 1 half twist. What about this one? That's going to be quite interesting to work out. If I stretch this, so keep these parallel to each other. That should enable me to identify how many twists we are left with. I don't know how many it's going to be because I thought I'd done this and now I'm not sure. So that's 2 half twists to end up the way it started. And that's 2 half twists again, Toni. We've got 2 half twists. So this one is not Mobius, but this one is. But this one is twice as long.
Interesting.
The skinny one is twice as long, and it's one loop, but it's not Mobius. Where's the original? What's left?
That's really interesting.
Yeah.
Okay. So there's a one that's half the width with the blue line down the middle, which is a Mobius strip. It hasn't changed, but you cut off what you cut off from it. It turned out to be a single strip. You might have thought there would be 3 pieces, but there's only 2. And each of those, the single strip was twice as long. So, recapping on that, we've got, if the blue line is drawn along the center of the cylinder, Caroline has just showed us, so what we get is the result's 2 cylinders, half the width of the original. That's what happens there. And if we do something similar with a Mobius strip, we describe what we've just seen, what we expected to happen. Now imagine it, think about it and imagine it. Caroline's just showed you. And that's what happens. And what Caroline showed us with that is that it could be rearranged into a rectangle or square with 4 half twists. So it had quite a different character from the original Mobius strip. And then, can you imagine now in your mind's eye, it's about visualizing something, thinking about that. What happens when we cut this Mobius strip? It has 1 twist, or 1 half twist really, all the way around along the red line, 1/4 of the way across the strip. What would we expect to happen, and what would the resulting strip look like? Would it be narrower or longer, and how many twists would it have? Imagine it. There's the result, what Caroline showed us. The strip, the one which has the blue line down the center, which came from the middle of our original Mobius band, it's the same length as the original, and the other one's twice as long, and that one had 4 half twists in it. Not 1 half twist, but 4. Okay, so we're ready. We've really finished our
we have, but I've got a couple of tricks up my sleeve, Toni.
Oh right, let's.
Could we do a couple of tricks? We've got time.
Yes, please. Yes.
Okay. Let's see. Let's have you and me. There we go. Now, what I've got. Can you see what I'm doing, Toni?
Yes.
One, is something that. What is the name of your lovely friend that did the
Tadashi?
Okay, so we take a sheet of A4 paper. Doesn't matter what size it is. Any rectangle is fine. Wait, topologically, you wouldn't even need to use a rectangle. I'm using scrap paper here, so that's why there's a line on it. We always use scrap paper if we can. I'm folding it in 4. No mystery there. Nothing special required. Now, I'm going to take my scissors and I'm going to cut out the 4 loose sheets. So I'm going to keep the fold and get rid of the edges. I'm going to cut out an L shape. What shape am I going to get with this remaining? When I open it out, what shape am I going to get? I've got a T.
I think you're going to get a cross. Yay.
Quite right. I've got a cross. Now, what I'm going to do here is I'm going to join I need some scrap paper to lean on here. That's not scrap. Oh, well, I'll clean it off the desk later. I'm going to join these two together. This was taught to me by Hattie Maths, by the way, Sue Brown, who somebody else taught it to her, but she taught it to me. Right, now we have a cylinder and with two long bits. But what we're going to do here now is we're going to join these together. But we're not going to join them together like a cylinder. We're going to do a Mobius twist on them, a half twist. So we'll have a Mobius strip there. Perfect. So we don't just join them.
Half a twist.
Half a twist. Now, first thing we're going to do is cut halfway down this little cylinder here, a bit like a napkin holder, napkin ring. Feel like it's Christmas with my napkin ring. Let's see what is going to happen. What is it going to look like when I finish cutting through halfway through this napkin ring, this cylinder? What are we going to have? Ta-da!
Oh.
Handcuffs.
And the other one that was the Mobius strip is now sort of stretched out.
It's straightened out.
Oh, wow. That's interesting.
If you look very carefully, you might have noticed something, but I'm not going to point it out. Now, what's going to happen when I cut down what was the pathway of the Mobius strip? What are we going to end up with?
Just a picture frame. It hasn't got any overs and unders at the corners, has it?
Nothing. It's just a 2D picture frame. That's it. I've got one more nice little one. If you like to see it.
Yes.
Okay. So I've got a strip of paper. This is just cashier. I get this stuff that you use on the cash machines. But on one end, I've made 4 fingers, nice and long. It's much better if you make them nice and long. Again, Hattie Maths showed me this. Now I'm going to get lots of lovely glue on here to give me some flexibility. Splutch, splutch, lots of lovely, lovely glue. Unless I was using double-sided tape, there's no real way of pre-preparing this because the glue has to work when you use it. So for the first finger number 1, I'm just going to stick it straight on. Am I? Yes. Finger number 2 is going to be stuck round like a Mobius twist. Finger number 3 is going to go into position 4.
And is that straight, or have you?
Into position 3. It's not quite straight, but topologically it's the same.
Okay, you haven't given a half twist to either finger 3 or 4.
No.
Okay.
Thank you.
But you did to finger 2.
You did to finger 2 half twisted. You can see because it's white. The others are all still straight down. They still have the same orientation as they had to start off with. There's other different variants that you can do of this. So the first thing I'm going to do is I'm going to cut it in half. So what is going to happen when I cut this in half? What am I going to end up with?
Oh, I find it really difficult to imagine. I think there's going to be a Mobius part of it, which it's difficult to think about. It's really hard to imagine.
There's lots of different ways you can place the fingers. You can experiment doing all kinds of different things and have a guess, see what's going to happen. So we have 2 cylinders.
Oh,
with some wonky joins.
What do you mean wonky joins?
Well, we've still got these wonky joins here because I made them wonky.
Yeah, you did. You mean the fingers are crossed, but are there any twists there, Caroline?
See, what I did between the first 2 fingers and the second 2 fingers is there's no connection between them. So all I've done is separate the first 2 fingers from the second 2 fingers. So there was nothing very interesting there, but it's still a surprise, isn't it? You don't know what you're going to get. So now let's take this one, which has one that's stuck straight on and one that has a Mobius twist. Now I'm going to separate fingers number 1 and 2. What are we going to get? There's so many different ways you can experiment with these fingers. And you can do more fingers, you can do less fingers. You can really have a good time experimenting with them. So finger number 1, that was just joined straight off, of course, is just a cylinder, topologically anyway. Okay, finger number 2, which I twisted round, is, if it hadn't stuck to itself, is a Mobius, because that's what I created. It's just a 1 finger width Mobius.
Wow. That's interesting.
What about fingers number 3 and 4? All I did was cross them over. So all I did, I didn't change their orientation. What is going to happen? We have seen the 2D flat come out from all kinds of twists and turns with the handcuffs. What is going to happen? We've seen squares that won't be Mobiuses. We've seen triangles that turn into Mobius strips. What is going to happen with these 2 crossed over fingers? Interestingly, even though neither one of them was a Mobius strip, we now have a loop that's twice as long. Now let's see how many twists it has in it. It has...
Is it Mobius or has it got 2 half twists?
It has 1 half twist, I believe. We have created
a Mobius strip.
A Mobius strip just by
crossing the fingers.
By crossing the fingers. And it's twice as long.
That is amazing. That is such a good demo.
And there's so many ideas that people have had, and so many different experiments. You think, well, what if this? What can happen? I get this when I do demonstrations and shows. Oh, well, what if you did this? I'm like, great. Why don't you do it? You do it.
Yes. I think this is lovely because
experiment.
You do it with scrap paper, as you've shown. No cost here. A simple pair of scissors, and children can do this for themselves, can't they? They can have endless fun playing with it. And the 2 ideas you've just shown us, Caroline, are really really something that's everybody's going to be surprised. So some children could prepare this and then go home and show it to their parents, and their parents are going to be amazed.
Absolutely. And then Toni, I think maybe we should keep it for Valentine's Day, Toni, to Ducky's heart.
Well, that's a really nice one, isn't it? Yes, I
haven't
think
worked
you're
out
right.
how to do that yet.
Well, we wanted to get Tadashi to join us, and he said he would. Yes, he said he would. So Maybe we should do it next year on Valentine's Day.
Invite him for Valentine's.
Yes, yes. And I don't know whether he's seen your finger crossing thing. I think he might have done, because he's into all these showman tricks, and maybe he hasn't though. Wouldn't it be lovely to show him something that you haven't done? Tadashi's a professor. He's a good friend of mine. He was a professor at Stanford University, and he's a serious mathematician. But in his spare time, he's a magician.
And he's a great showman. He's such panache, doesn't he? He's very entertaining.
Yes. And I had a wonderful time at his wedding, because he invited some of his other friends who were magicians, and they were doing, and one of his friends was doing tricks, and he even took Lisa's wedding ring and said, I hope you trust me. And
never trust a magician.
And it did seem to disappear, but he did give it to her back in the end. He did make it disappear.
I never understand how they managed to get it into a sealed bottle. I mean, I know lots of magicians, but I don't want to find out how the magic works, because I still find it really fascinating. And when I know how it works, I appreciate the performance. And you say, oh, well, that was really well performed. When it's done badly, you're like, I know how they've done it. It kind of takes all the mystery away.
I don't know. I mean, I just imagine one of the things they need to do is to make you focus your attention on something else, so that you don't notice the bit of sleight of hand.
It's called misdirection. It's a technical word. And then you've also got something very psychological, lots of psychology involved in magic, and that's called the suspension of disbelief. So you have to be good enough to suspend the disbelief of your audience, so that they believe that what you're doing is magic.
Yes.
And those are technical terms. Suspension of disbelief. I did not make that up.
Yes, but here, really, these aren't tricks. These are things that anybody can test out for themselves. But they are quite hard to visualize. And as Caroline and I have shown you today, inadvertently, we didn't mean to do it. We weren't quite sure after we really got launched on this voyage. We weren't absolutely sure how many half twists there were. We thought we knew, and then we weren't sure, so we needed to check on it. And it really needs two people, Caroline, and we're doing this on our own. And so what you need to do really is you need to take one person, take one end of the strip, and the other person holds the other end. And it's very difficult to do if you're just on your own. And then
you could tape it to a table. You could tape it to a surface too.
I suppose you could.
Yeah.
But then you just carefully do half, just round 180 degrees, as you would to make a Mobius strip, and then another half twist, and see how many half twists it is. You can just count it that way. Because the way you were doing it, Caroline, is really, really hard to get it right.
Yeah, that's true. And the thing is that this demonstrates how you can struggle with a maths problem very well, because you can keep thinking, oh, I've got it now, and then you go back and, oh, no, that's not it. Then you think, oh, I've got it now. Oh, no, I still haven't got it. And that's exactly what was happening with the Mobius strip. We thought we knew how many twists it had, and we were wrong, which is fine. It was absolutely fine. Now we're probably going to go back and double check again. But this is just demonstrating how you come to conclusions in mathematics. And then you can have people that have published a proof. Everybody in the world agrees it's a proof, and then it gets disproved a few years later. So this happens, and that's the life of a mathematician, isn't it, Toni?
Yeah, but we're usually this. Don't believe that what we've been showing you is topology. It's really just playing around in the shallows at the edge of the ocean. Actually,
we couldn't even do that. It's lots of
Anyway,
fun.
we've
I
had a
know
bit
it's
of fun, and we hope you have. And so I think it's time to say goodbye.
Yes, it is. Thank you so much. And we'll see you next time. Next week we're doing a Maths Week Ireland special. And the subject is, I can never remember the reptiles. We're doing mathematical reptiles next week. So please do join us.
These are not cold-blooded green creatures.
Toni, you spoiled Go on. No, they're not cold-blooded green creatures.
So next week, then, it's going to be reptiles.
And that be
bye-bye, everyone.
Join us and be part of Maths Week. Maths Week Ireland. Bye-bye.
Bye-bye, everyone. Bye-bye.